Have you ever wondered what forces a structure must resist every day? A building is constantly subjected to many types of loads, not just its own weight. People moving inside, strong winds, earthquakes, vehicles, furniture, and even snow in some regions all create loads that engineers must consider during design. In TE Leçon, we'll explain the main types of loads in structural design and why understanding them is essential for safe engineering. In structural engineering, a load is any force or action that causes stress, deformation, or displacement in a structure. Simply put, loads push or pull. Engineers must estimate these loads carefully because structures are designed to resist them safely throughout their lifetime. Loads, constant, variable, environment, or accidental. The first element load is dead load. Dead loads are the permanent weights of the structure itself, remaining constant throughout its life. Examples include the weight of beams and columns, slabs, walls, roofing materials, and permanent finishes. These are easier to estimate using unit material weights. Unlike dead loads, live loads are variable. They represent loads that change over time depending on how the structure is used, such as people or furniture. Live loads are more uncertain, so building codes specify standard values for different uses like residential buildings, offices, or parking structures. Wind can exert significant pressure on structures, especially tall buildings. These loads depend on wind speed, building height, shape, and surrounding terrain. Wind creates pressure on one side and suction on the other. Engineers must design for lateral movement and vibration to ensure stability and occupant comfort. Earthquake loads are critical in seismic regions. Unlike other loads, earthquakes generate dynamic forces caused by sudden ground motion. Engineers design structures to absorb and dissipate seismic energy, often by ensuring ductile behavior, allowing the structure to flex without collapsing. Structures must also resist environmental loads, such as snow loads on roofs, temperature effects, rain ponding, and soil pressure on retaining walls. In reality, structures rarely experience just one load at a time. A building may experience dead, live, and wind loads simultaneously. Design codes specify how different loads should be combined and factored to ensure safety. We will discuss load combinations in detail in our next lesson. Maries, structures are designed to resist dead, live, wind, earthquake, and environmental loads. Understanding these is the first step in structural design. Like the video, subscribe to Kussitta CENG Solutions and comment if you want examples of load calculations in real buildings. See you next time. Kussitta CENG Solutions, engineering made simple and practical.